What's up, YouTubers? I got a mess of non-OSHA approved cords here. So for today's video, I'm going to do sort of like a viewer question that dealt with extension cords. I got a bunch that'll probably help them out. And I got a little bit of time before work, so why not shoot a video to help some people out and we can all talk about this. So let's get into it. So the viewer's question was regarding extension cords. Now, he wanted to know if it was possible, I guess, to replace the cord on a machine because his was pretty short and his leads were also short, and as well as just ideas on extension cords. So let's talk about the first thing, which is, can you replace a cord on a welder? I'll have to apologize. In the time frame I have to cover this, I didn't want to move all my welders out to get a better shot, but I think you can see. So welders all have different methods to retain a cord to the unit. Better welders, like this Firepower, and you can't see this ESAB back here, but it's the same, as well as the Miller, use a real nice, like locking, bushing of sorts that the cord passes through and it locks down. Those are really easy to pull the cord through that, like if you want to change the cord. Some of them, they're like staked and molded on where they're not really easily replaceable. So these actually are. Now internally, depending on how they have it wired, it may or may not be easily replaceable. So what I found is in the Miller, I've taken that apart, and I've taken a few ESABs apart. I have not taken this or my little Rogue 200. But normally, better welders, the cord has a bunch of terminal eyes on it and it goes to a switch, or the switch just basically bare wires go into it and they're staked down or bolted down. So it's fairly easy. If you wanted to extend the cord longer, you could actually do that. Cheaper welders, I find the cords are soldered through a bunch of boards, and replacing it's a pain in the ass. So it really depends on how much effort you want to put into actually replacing it. But that is an option. Now, realistically, for warranty's sake, it's hard to say that, well, if you replace the cord and then the thing failed and you send it in for service, the company may deny your warranty claim. And I know that sounds stupid and we might all grumble about it, but if you have a welder with, that's shorted out or has problems, and here's a non-factory, non-UL listed cord on it, they probably, I'd say 11 out of 10 companies are going to have a problem with that. Okay, so I think the smarter thing is to use an extension cord, but yeah, you could replace it depending on the welder. So extension cord wise, let's just talk about the basics really quick. So here is a crappy and borderline dangerous cord here. So this pulled out of this, and what I need to do is cut this off, resplice on a new end that's actually decent, and fix this, which I will do sometime soon. But for the time being, this is like your standard cheap extension cord. The main thing you want to concern yourself with cords, if you're running on 120, get a 10 gauge extension cord. One of the biggest issues is that welders pull a lot of power. They actually pull far more than 20 amps on a 20 amp circuit. Your standard 140 amp MIG welder actually pulls somewhere, I'm not joking, somewhere around 35 amps if you max it out. The reason they can do that is because the breaker trips on a thermal cycle, and at 140 amp output, which is about 35 amps pull, the breaker will last about 20 to 30 seconds before it kicks out. Well, that's long enough to get a weld done, and due to the duty cycle of the welder, it's not going to probably trip your breaker. That's why this is a 12 gauge cord. If you run a 12 extension cord on a 140 amp MIG welder, you're going to end up probably melting this if you max the welder out. Now, I know you'll say, well, a 20 amp circuit has number 12 wire in the circuit. That is correct. And yes, you will pull far more than 20 amps through that, but for an extension cord, you have control over it. You want to be smart about it. Use, I don't care if it's a 10-foot cord, or especially if it's over 30, 40 feet, get a number 10. I know they're expensive. They don't give them away, but your welder won't see voltage drop due to the long length of cable and the crappy terminal ends and all of that these things use. So get a number 10 cable for your 140 amp MIG welder on 120, 10 gauge, that's it. Now for heavier duty welding, now this is an adapter I have for my generator. Let me pull it off. So this is a standard NEMA, probably 50R. Let me see what, it doesn't really say, but this is a 50 amp rated cable, and I don't know what all these safety warnings are. Probably, yeah, don't use in the rain, don't pee on it, don't trip over it, whatever. So this is a heavy duty cord. You can see by the size of it, very heavy duty. Now this is a 8 gauge, yeah, 8 gauge cord. If you're running on 240 and you want a 25-foot extension, 8 gauge is your minimum. So being that this is 8 gauge, this is probably only rated for 30 amps would be my guess. Let me see, yeah, I don't see anything for amperage wise. But ideally for 240 volt for a 50 amp, for a true 50 amp plug, and you got a big welder on it, you're going to want to use a 6 gauge extension. Don't even screw around with a number 8. If your welder draws somewhere around 30-35 amps on 240 volts, so say like a 200 amp MIG machine, you'll be all right with this number 8. That'll be all right, but honestly, extension cords, you're better off getting a bigger size and then not needing it than getting too small of one and having voltage loss and your welder struggling. So it's something to think of. But this cord, number 8, I bought this one off of Amazon. I would not recommend this particular unit, which is very common on Amazon. You can tell by the blue and the purple. This side is fine, like I have no issue with it, but over here, this plug-in, not only, I dropped it on the ground once or twice and it cracked through here, so that's kind of a problem. I should really rip this off and put a new head on it and everything. But not only that, I am not exaggerating. Don't mind that right there. Get that out of the way. I cannot separate these two. I tried a screwdriver, a pry bar. This head on this thing is so tight fitting on any plug I've ever put in it that it's almost impossible to separate them. So I would recommend a better cord. I believe this was a Southwire brand. You'll see it on Amazon. I would find a better cord than this. This head is simply too tight, which I get it, if the terminal's loose, it's gonna arc and short and all of that, but I wouldn't buy this one. It's been an issue for me since the beginning, and like I said, this plastic is too hard. It just cracks if you drop it even from a couple feet. Now, if you're wondering, what the hell is this apparatus that I have attached to here? Well, let me explain. So this is a totally non-UL approved, janky, don't do this at home type situation. What I got here is a very short extension that allows me to plug a welder in here, and then I'm able to amp clamp the power wires to get a reading on draw. I made this specifically for the purpose of testing. This is not something that if I were you at home I would do. Now, I'm not really at too much of a risk of getting shocked because I simply clamp an amp meter on there through this wire, and I can get, you know, readings to calculate efficiencies and whatnot on welders. And I got a bunch of videos regarding that coming out, so I kind of had to do this. Now, like I said, this isn't really a safety issue, but I wouldn't do this at home. I can't recommend it. It's for testing purposes only. You know, do your due diligence on that. But an option you do have, and the reason I bring this up, besides the fact I can't pull that apart, I'm not even joking on that, is that you could make yourself your own extension cord. Is it going to be cheaper than buying a pre-made one? I would say probably not. Is it going to be as nicely made? I would say probably not. Like, this box here is really designed to be mounted on a wall. It's not really designed to be the head of an extension cord. What concerns me with doing something like this, or even recommending it for an extension cord, is, well, first off, this thing's even more brittle than this. If this thing dropped, I could see this breaking off, and then you have exposed live wires, and you're not dealing with a 9-volt battery here, so you're going to get more than a tickle. So that's not good. And then not only that, if you were to spill anything anywhere around here, it's almost instantaneously going to be getting into here. I mean, look at it. It's got holes. This is not what you should do to make a cord. They do make ends that you can clamp on your cord like this. This is all nice molded and all that, but that clamp on, use one of those. I did this for testing purposes, but you could make your own cord with decent ends. Like this is an end that would be pretty decent. Has a clamp to hold this. I mean, this is very, very stout, but you have options. Now, for industry, you don't see too much of 240 plugs that look like this. In industry, they use rotary lock connectors and twist lock. Let me show you those. So my generator uses this, but here is a 240 volt plug, and this is a twist lock. So now this plug in particular has a neutral wire, 2 hots and a ground. With welders, we don't use the neutral wire. We don't need it because the welder operates on 240 volts. It does not need 120. So these twist lock connectors are available in 30 amp. I believe there's some form of it's available in 40 amp, or excuse me, 50 amp, but this, the most common, is a 30 amp. When you get into industrial environments, especially with 3-phase power, a vast majority of them use twist lock connectors. So this is something you would see on a construction site or a factory more so than your home. But these are a very good option to make your extension cord. You could cut the end of your welder off, put one of these on, and then use an extension cord with these. So all your ends will be twist locks. Now, this is an adapter to go from twist lock to conventional. You could also make an adapter that would go from the female twist lock to a male plug like this, so that you could plug into a normal 240 outlet. So again, it depends on your situation. Because I run on a generator a lot, I have to use this guy because my generator does not have a NEMA 650 plug. So I have to use twist lock from it and then convert it. But let's, I guess, go to conclusion on this. So I know I covered a lot of this stuff probably in more detail than was really warranted, but I guess the takeaway, the key takeaway here for you guys should be buy the bigger cord. Welders are not light bulbs, they're not computers, they draw a tremendous amount of power, and the last thing you want to do is cause your extension cord to be a bottleneck and end up melting it or whatever, or damaging your welder because you're trying to output max power and your power wire is glowing because of the resistance. So buy the bigger cord. And to reiterate that, on 120, get a 10 gauge cord. Don't eat 12 gauge has no business being hooked to a welder on an extension cord, 10 gauge only. For 240 volt, I would recommend 8 gauge is a minimum, and I would suggest, if you can get it, 6 gauge. Yeah, it's a heavy ass cord. Yeah, it sucks to haul around, but you know what? It'll last for you, and there's no question that it will provide the power. And something else I didn't mention that I almost forgot, always buy the longer extension cord. Because listen to me, that's probably the best advice I've ever given on this channel. Every time I swear I buy an extension cord, I have an option of a 25 or a 50. And I'm like, oh, I'll just buy the 25 because it's cheaper. And then I show up on site somewhere and I swear it's 2 feet too short every time. So if you have the option, buy a 50 instead of a 25. If you're looking at a 50, buy a 75 or a 100. Don't play around. Like, trust me, all too often it's far too short. So get the longer cord, get the big wire. It's going to cost you $100, $200. I hate to say it, man, it's the price of copper, but you'll have something that you can rely on that won't cause any damage to anything, will last forever. So that's my recommendation, and don't buy this brand off of Amazon, even though it's well regarded. Don't. So either build it yourself or preferably get a better brand. So with that said, if you got any comments, questions, ideas, opinions, you know where to leave them. Till next time.